Vectra'dan yapay zekanın siber güvenlikteki faydalarını anlatmak üzere Abdurrezzak Bey'e bırakıyoruz. The stage is yours, Abdurrezzak.
Thank you very much. Thanks a lot. Assalamu alaikum everyone.
Just a second for the introduction. Bu oturumun sonunda bir yarışmamız olacak. Kahoot üzerinden bir bulmaca, bir bilmece yarışması olacak. Şimdiden telefonlarınıza Kahoot uygulamasını yüklerseniz çok seviniriz. Böylece zaman kazanmış oluruz.
Sorry? Oh yeah, sure, by all means. Thank you. So, good evening everyone. Thank you very much. I'll be speaking in English, so if you have any question or something, you just let us know. My name is Abdurrezzak Zahran. You can call me AZ. I'm working for Vectra since like 1 year now, and I'm based in Middle East and covering Middle East, Turkey, and North Africa. So today we are going to talk about how we can empower the threat hunters with an AI tool, so it can automate the threat hunting approach and save your time, resources, and at the end of the day, the risk. So we all know that any network, it has a parameter security solutions, which is very important and very essential to any network. Like talking about the firewalls, the proxies, the endpoint solutions itself. This is all very important. This is all essential in any network. But the thing is that nowadays, on daily basis, any cybersecurity team, the question that they want to answer is, on daily basis, 24/7, are we under attack, right? And this is the challenge. And unfortunately, with the existence of all the security controls that we have in the prevention phase, it's very important, but the fact is that the attacker, in one way or another, they are successful in doing stealthy attacks. And we all know about recently the Marriott. They have been hacked or compromised since 4 years, and there is exfiltration of users' information has been encrypted and exfiltrated to outside the network itself. So, on daily basis, on any network, you might have hundreds or sometimes thousands of events that you need to go through to ask or to understand whether one of those events actually a signal of an attack or not, right? So this approach, it's manual approach. It needs a lot of time, a lot of resources, and at the end of the day, risk. As per Mandiant from FireEye, once there is an attack, a successful stealthy attack, so until you came to know, once the attack starts, until you came to know that you are under attack, until you pinpoint the attack itself to start the investigations, it takes around 100+ days to find an attacker. And this is average on the overall world. For the Middle East region, the MENA region, actually it's more than that. And for many attacks, it's for sure more than this. Even in Pakistan, since 2 weeks, there was a bank. They've been hacked since 1.5 years, and they have no idea that they are under attack. One of the examples. So the idea is that the attack active phase, it's too much you cannot handle, 100+ days. And the idea of Vectra and the solution of Vectra is empowering your threat hunters with an AI to automate that phase, threat hunting phase, so you can take it immediately to the cleanup phase, which is forensics, incident response, and mitigation, if needed. So, you always need more resources, and by the way, by 2022, there will be 350,000 unfulfilled European cybersecurity jobs by 2022. So you always need more resources, but the question is that do you have the budget or not? I mean, in general, on a higher level. And nowadays, we saw that a lot of, or the customer approaches or the market approach in cybersecurity, and the budgets have been spent on preventions only, prevention technologies, which is okay, important, yeah, but now it's increasing on investing these budgets on detection and response. Because of the nature of the attacks, that prevention only will not be the solution to catch those attackers. Even the attackers nowadays, they are using maybe not malwares, maybe they are using living off the ground tools like PSExec tools, for example, or Bloodhound, or I mean, this is just a normal tools that the people use. It doesn't have signatures. So in Vectra, and I'll brief this slide, but in Vectra, first of all, before we apply the AI, the fact is that if you want to find a signal of any attack, the fact is that the signal will always be inside the raw network traffic, the real network traffic, not inside the logs, not inside in any other resources. No, it's actually always will be in the real network traffic. So that's why Vectra, we capture the traffic, the raw network traffic from capture based on endpoint agents because it doesn't cover IoTs. We don't consider NetFlow, and we don't consider logs for threat hunting. SIM is very important tool we can talk about in the upcoming slides, but for threat hunting, it's noisy, but it's very important for other use cases. I'm sorry, the slide is not. Okay, now it's working. So talking about AI, I think all of us hear about AI. This is a buzzword nowadays, right? Everyone is saying AI, machine learning. Anyone don't hear about AI nowadays? Nobody. Even my kids now, that machine learning, AI, everyone. So everyone is using AI and machine learning. And the fact is that AI, it's not just saying that we have AI. Having simple machine learning algorithm is not an AI. So we need to look at AI like it's a problem that we need to solve. Okay, and if we have many problems that we need to solve using AI, we need to look at each and single problem alone and using the right data science mathematics disciplines to write the special algorithms to address these problems. In the cybersecurity in Vectra, we have security research team. Those security research team characterizing the fundamental attacker behaviors. Nowadays, if the attacker want to do, let's say, command and control, and across the kill chain itself, so on higher level, command and control, reconnaissance, lateral movement, botnet, or even exfiltration, the attacker might use how many tools? Infinite tools, right? You can create a lot of zero-day tools because you can do that, right? But at the end of the day, if the attacker want to do command and control, as an example, the attacker might use, as we said, infinite tools, but the attacker will have a finite methodologies to do the command and control. So if the attacker want to do command and control, maybe the attacker will use maybe external remote access as a methodology, maybe peer-to-peer, maybe Tor activity. So the methodologies of doing the attack, it's finite, but the tools, it's infinite. So our approach is we defining those finite attacker methodologies, behaviors, okay? And based on that, as an example, the external remote access, our security research team working with the data science team to build a special algorithm, for example, to address how external remote access will look like, to address how Tor activity, to address how SQL injection, to address how cryptocurrency mining, etc., file share enumeration, across the whole kill chain itself. So that's why at the end of the day, the models that we have is an attacker behavioral models. It's not giving anomaly detections. It's giving a threat detections. And in the upcoming slide, we'll see an example for one of the customers in terms of numbers. So our team is using, regardless of the number of algorithms, but our team is using more than 10 types of data science mathematics disciplines to write those algorithms in terms of whether it's unsupervised, supervised, deep learning, or even machine learning. So like we use, if you're interested, we use like k-mean clustering, we use random forest, Bayesian network, naive Bayes. There is many mathematical disciplines that you can use to write the algorithms, but the idea is that we use a mix of supervised and unsupervised, and the intersection between them, it gives you a deep learning, and we can see that in the upcoming slides. And you can see this is just an example. For each one of this attacker behavior or methodologies, we are building a special algorithm to address how this behavior will looks like. Okay? So we all know that attacks, let's say, like Wannacry, right? Wannacry, it's well known. Everyone knows Wannacry. But by the way, Wannacry, even before it became famous, Wannacry itself was very well known. But why it became famous? Because Wannacry just took the advantage of the eternal blue vulnerability in the SMB protocol in Windows. So they exploited that, the attackers, so they become spreading east and west very fast and becoming a destructive one. So do you know that Wannacry itself, it used the same methodology that was used by Conficker. Conficker, it's also one of the attack types. It was used 10 years ago. So Conficker used the same techniques to do the attack 10 years ago, and Wannacry repeated the same. So it's some of the attackers, or most of the attacks nowadays, as we said, is slow, and some of them are fast. So what we do actually in Vectra, we capture traffic on real time, and we apply our AI algorithms, and we are firing detections. And for each detection, there will be score, okay? And this score of any detection will be based on similar activities over the time. In other words, nowadays, the attackers, as we said, slow and low. So the attacker is not doing one activity one time and sleep. Maybe the activity itself will be separated into stages. Maybe he will do very low activity now, and after 2 days will repeat the same activity but in different way, or I mean to complete the activity itself. So you need to have a deep learning and track this activity over the time, and this is what we have actually in Vectra. We are tracking all these activities over the time, and based on that we are giving a score for each detection. Each detection could be, or each detection will be in a host, and the host itself will have a score, and the score of the host also will be based on combination of behaviors over the time. I mean, if there is a host with many detection, this host will have also a score based on those detections, and the host itself and the scoring of the host and different hosts may participate in an attack campaign. I mean, different hosts are participating in the same attack, which we call it an attack campaign, which you would like to have a look at as a bird eye to see where was patient 0 and how that was happened, and how was patient 0, let's say host A moved to host B and host C, so you can address the potential attack at the early stages before it's becoming massive destruction or destructive. As an example of one of our customers in Europe that is using the platform, there was, across 30 days evaluation, there was almost 200,000 hosts observed over the time, over the 30 days. And from this 200,000 hosts, there was 30,000 events flagged. And those 30,000 events per 30 day, you can say 1,000 event per day. And you can imagine having 1,000 event per day, how many time and resources you need to address all of them, and whether it's good or not, but at the end of the day, you will miss a lot, and maybe the signal is not there. In Vectra, from this 30,000 host detection, we fired 1,249 detections. Those detections was a real threat actors and attack vector detections. Those are not anomaly detections. And those detections actually was on 675 hosts. And this host could be IoT or desktops, laptops, servers, or whatever. But the idea is that this 675 hosts across the 30 days, we summarize them based on the threat and certainty on the x-axis score, And threat score is in the y-axis, sorry, from 0 to 100, and the critical events, or the critical host from the 600 hosts, was 63 hosts. So if you make the simple calculation, 63 hosts across 30 days, in average, there was 2 critical hosts per day that needs an immediate action from the customer to be taken, instead of being lost inside a lot of events that is anomalies or misconfiguration that you need to go through. That's why you can see, using the AI, you save time, you save resources, you will let your team focus on taking the signal, the high fidelity signal from Vectra of the real threat actors, and take it immediately and focusing their efforts into doing incident response, forensics, and mitigation. And this is what we need, right? Instead of being lost. And you can see at the end, the AI is helping and separate the signal of the attack from the overall noise that you have inside your network, so you can at the end of the day save the risk and take it to the next step, which is the needed goal. So this host severity summary, you can see, I mean, this is how the host dashboard, the main dashboard will looks like, and this is where the host severity summary is. And as an example, you can see this is our quadrant. I'm not sure the focus is not okay, but you can see the x-axis is the certainty, and the y-axis is the threat. And you can see here there is 5 critical hosts that you need to focus on. Usually our customers, even the largest customers here, in let's say in Turkey, we have references now. They have, let's say, more than 50,000 hosts, and now per day, they have 1 critical host per day as an average workload that need to be focused on and take an action on it, instead of having hundreds or maybe thousands of events. So from here, you can pivot into, you see this is here, Kennedy Mac device host itself. You can go to the host, you can find threat uncertainty of the host itself. Plus there is a detection, data smuggler, file share enumeration, suspicious Kerberos client, and each detection as well will have a threat uncertainty score. In terms of talking about the infrastructure of implementation, we as Vectra, we can work 100% on-prem. This is one of the important things. We can work 100% without any connection to the internet. So 100% air-gapped. And the algorithms is updated on monthly basis, and this update could be, actually it will be on monthly basis, and each update will have an update to the algorithms. And our implementation is simple. The largest brain, we have a device, hardware, and this hardware will be, and we only have hardware for the brain, and for the sensors, we have hardware and virtual sensors. But the hardware as a brain, the largest one, it is a 1 rack unit, can handle up to 60 gigabits per second, and up to 300 or maybe 500,000 hosts, which is 500,000. And the idea is that we would like to see north, south, east, west traffic inside your network, and we can implement a user and IoT, which is the enterprise network, in the data centers, whether as a physical sensor or as a virtual sensor. Also, we can be on the cloud as well. So you see here, you can implement in the data center, the brain itself, and you can implement other sensors around the network to capture this raw traffic. And this is the only traffic that we need. So no need for other type of traffic. Usually the implementation, it's not taking more than 1 hour, assuming that spam port or tap is already configured. But after that, you will start to see the detections and all of that. Vectra, we are only, in terms of integrations, Vectra, we are only automating the detection. So we are detection only, but we don't want to have another solution for response and saying that, yeah, if you need Vectra you need to do response, you need to buy a new product from Vectra. This is not our approach. Our approach is to be open in integration. We would like to integrate with what you already have inside your network, and you can think about it like Vectra is the brain, giving you a signal of a real threat detections, and you can integrate with the muscles that you have in the network, like maybe, let's say, orchestration platforms, NAC solutions, or maybe firewalls, or endpoints, EDRs, without mentioning vendor names. But we are very open in integration. We have native integrations. Talking about SIEM, SIEM is a very important tool, but it's very useful and important and essential for many use cases. But usually the SIEM solutions, vendors actually, they are our technology partners. They would like to integrate with us because they want our report to be sent to SIEM, okay? And with the existence of Vectra, it will let you even take more advantage of the SIEM, because the reports of Vectra will be inside the SIEM. So you will start from the SIEM and Vectra report inside the SIEM as your starting point, high fidelity starting point. So you can take it as a forensics inside the other tools, or maybe the SIEM on the right data sets to do that special forensics instead of being lost. So that's in general the integration. We can integrate with orchestration, as we said, and with endpoints, NAC, and firewalls. And at the end of the day, integration is just a REST API, which is technically can be done with any vendor that is open to that. We have another product, which is Recall. Yeah, we capture the traffic on real time. We fire detections. And this solution that I've talked about, it's Cognito Detect. It's the AI part, okay? The other part is Cognito Recall. This one, it's not an AI part at all, because we capture traffic on real time. We fire the detections, and the other traffic will be dropped as a metadata. But if you want to store all of this metadata, your full-fledged network metadata, not the full payload, because the signal will always be in the full-fledged packet header of an attack. You don't need always to look at the payload, okay? You can store this metadata, all of it related to the network, regardless if there is a detection or not. So Cognito Detect is the overall solution that we've talked about. Recall, it's actually storing all the metadata that you are capturing in terms of full-fledged layer 7 breakdown, talking about Kerberos, SMB, DCRPC, and all the full-fledged, even the SMB itself. It's the recall itself, the Cognito Recall, it's used for forensics. So after Detect, you can use the tools that you have for forensics, but if you want, optionally, you can buy Recall. But what is the important thing about Recall as a forensic? It is, first of all, the data itself, it's focusing only on the full-fledged packet header, so you don't need to store all the payload because it's not needed in all the forensics that you want. Plus, you can scale very easily. But at the end of the day, unfortunately, so far, we have this solution. The Recall only is in the cloud, but this is, I know that this is not acceptable by many organizations. But their Detect part, the Detect solution, it's 100% on a premise, zero cloud, zero internet connectivity, which is, I mean, the thing that we have. And at the end of the day, we have nowadays Detect implemented in some of the customers here. Some of them are referenceable and some of them are not. But one of the customers that we have is Hepsi Burada, which is, I think, everyone buy from them, right? So we have, as I said, we have many references. We have references in Saudi Arabia, in Qatar. We have references in UAE. But usually, at the end, our customers, whom they are using Vectra, the feedback was Vectra saving a lot of time for the team, saving the resources of the team. And instead of being lost, they give them as a good start for a high fidelity threat actors and attack vectors, so you can take it immediately to what you want to do. And this is actually what AI it's all about and why we use that. So anyone have any question so far? Very good. So thank you very much. I appreciate your time and joining Shield and my session. So if you have any question, you can share it with Innovera or with me directly, and it will be our pleasure to implement a POC for you in the region here for sure. And usually the POC will be like a real implementation. So it's not like POC, a limited scope or not. So thank you very much. Thank you. I appreciate it.
Thank you very much, Abdurrazak.